Hi, this is Rajesh. Today we are going to learn one of the important concepts of quadratic equations, that is nature of the roots of quadratic equation. We all know that general form of a quadratic equation is ax square plus bx plus c is equal to 0. Ax square plus bx plus c is equal to 0. A is coefficient of x square, b is coefficient of x, and c is constant, isn't it? And also every quadratic equation has two roots. To find roots of a quadratic equation, we have different methods. Those are factorization method, completing the square method, and formula method. Whenever we are unable to find roots of a quadratic equation by using factorization method, we will go for formula method. That is, x is equal to minus b plus or minus square root of p square minus 4ac by 2a. See here, I have taken in the formula plus or minus. It means one time we need to take plus and another time we need to take minus. So when I take plus, minus b plus square root of b square minus 4ac by 2a is one root. When I take minus, minus b minus square root of b square minus 4ac by 2a is another root. So after finding the roots, we can say given two roots are, or finding two roots are real and distinct, or else real and equal, or else those are not real roots, isn't it? Is there any method without finding the roots can we say given two roots, it means whatever roots we are getting for a quadratic equation are real and distinct, are real and equal, are imaginary roots. Imaginary roots are nothing but not real numbers. Yes, we have one method, that is discriminant. If you find the value of discriminant, that value is greater than 0, roots are real and distinct. Distinct means different, real and different. If the discriminant value is exactly equal to 0, roots are real and equal. If the discriminant value is less than 0, we will get roots are imaginary numbers, means not real numbers. See here, what is discriminant? Here discriminant is nothing but b square minus 4ac. Generally discriminant is represented with the letter discriminant is nothing but discriminant is equal to b square minus 4ac. This is called discriminant. It is represented by the letter capital D or else delta, isn't it? Discriminant is represented by the letter capital D or delta. See, the value, if I give you one quadratic equation, so for that we need to find discriminant, that is D. D is equal to b square minus 4ac. The value of this one is greater than 0. D, b square minus 4ac is greater than 0. At that time, roots are real and distinct. Real and distinct, isn't it? We will get two roots. Those two roots are real and distinct, different. When the value b square minus 4ac is greater than 0, discriminant is greater than 0. Suppose if it is perfect square, roots are rational and distinct. Roots are real and distinct. See here, b square minus 4ac is a perfect square. Perfect square means a number is multiplied by itself. Suppose 4, 2 2s are 4. Next 9, 3 3s are 9. 4 4s are 16. All those are perfect squares. B square minus 4ac is a perfect square. Roots are rational and distinct. Next, b square minus 4ac is greater than 0 and it is non-perfect square. At that time, we can say roots are irrational and distinct. Irrational and distinct. See here, b square minus 4ac is greater than 0. We can say roots are real and distinct. Next, b square minus 4ac is a perfect square. We can say roots are rational and distinct. B square minus 4ac is not a perfect square. At that time, roots are irrational and distinct. See here, we all know that a polynomial, 0 of the polynomial. In the polynomial chapter, we learned 0 of the polynomial. For what value of the variable the given polynomial is equal to 0, that is called 0 of the polynomial. Coming to the geometrical meaning of the 0 of a polynomial, a curve, how many times it touches the x-axis, those many zeros we have in the polynomial. Like that only, coming to the chapter quadratic equations, we have two roots. Okay, how many times a curve of the quadratic equation touches x-axis, those many roots we will get. See here, I told you quadratic equation has two roots. So when the discriminant d is greater than 0, at that time curve of the quadratic equation, graph of the quadratic equation will be like this. It will be like this, or it will be like this, or it will be like this. See here, it touches x-axis at two different points. So these are the roots of a quadratic equation. So this is geometrical meaning of the roots of a quadratic equation. When the discriminant is greater than 0, we will get two roots. Those are real and distinct. Like that only, b square minus 4ac is less than 0. b square minus 4ac is equal to 0. We will take. See case 1. This is case 1. Take this one as case 1. Next take case 2. Case 2. In that, b square minus 4ac is equal to 0. So here we can write d is equal to 0. At that time, we will get two roots are real and those are also equal. So simply we can say that roots are real and equal. See, if this discriminant b square minus 4ac is 0, this entire part will be 0. At that time, we will get normally x is equal to minus b plus or minus 0 by 2a. So we can write x is equal to minus b by 2a only. But every quadratic equation has two roots. So here only I got 1 minus b by 2a. So one the root is also we will get minus b by 2a only. When the value of the discriminant is equal to 0, we will get roots are real and equal. Real and equal. So roots are real and equal. Real and equal. Next. So what is the graph of the quadratic equation when the discriminant is equal to 0? See, we will get here like this. This is y-axis and this is x-axis. Graph will be like this. It touches x-axis only one point, that is x is equal to minus b by 2a. Minus b by 2a. Or else here we can take like this. Touches. Next here we can take like this. So the graph of a quadratic equation when the discriminant is equal to 0, we will get like this. It touches x-axis at only one place. But we will get two roots now. Those two roots are equal. So here only we will get two roots. Next, when the discriminant value is less than 0, take that one as case 3. Case 3. At that time, discriminant value b square minus 4ac is less than 0. D is less than 0 means we won't get roots are real numbers. We will get imaginary numbers. If b square minus 4ac, this part is less than 0, we will get imaginary numbers. So we won't get any real roots. So here roots are not real numbers, not real numbers. So what about graph of a quadratic equation when the discriminant is less than 0? See here, you will get like this. It won't touches x-axis. It won't touches x-axis. It won't touches x-axis. See here, this graph, it never intersect with the x-axis. So here we can say that when the discriminant value d is greater than 0, it has two roots. Those two roots are real and distinct. So graph of the quadratic equation when the roots are real and distinct, it will be like this. Okay. Next, discriminant value is equal to 0. Roots are real and equal. So graph of the quadratic equation will be like this. See, it touches x-axis only at one point. Therefore, the roots are minus b by 2a comma minus b by 2a. Next, coming to the case 3, that is discriminant is less than 0, we will get b square minus 4ac is less than 0. Roots are not real numbers. At that time, graph of the quadratic equation will be like this. It touches x-axis. Okay. Next. See here, I have written each and everything. Case 1, b square minus 4ac is greater than 0. Is greater than 0. Conclusion. Roots are real and distinct. Those are minus b plus square root of b square minus 4ac by 2a minus b minus square root of b square minus 4ac by 2a. At that time, graph of the quadratic equation will be like this. It touches x-axis 2 points. One is here, another one is here. One is here, another one is here. Like that, it touches x-axis with 2 times. Next, case 2. When the discriminant is equal to 0, b square minus 4ac is equal to 0. Roots are real and equal. At that time, roots will be minus b by 2a comma minus b by 2a. So, graph of the quadratic equation when the discriminant is equal to 0, we will get like this. It touches x-axis only at one point. Next, coming to the case 3, b square minus 4ac is less than 0, and then we will get roots are not real numbers. So graph of the quadratic equation when the discriminant is less than 0, it will become like this. It never touches with the x-axis. Okay, thank you.